Here we're going to look at finding the perimeter and the area of parallelograms and trapezoids. We're going to start by looking at parallelograms. First thing we have to do is recognize the shape of a parallelogram, and it's a lot like a rectangle where the top has been sort of shifted one direction and the bottom has stayed put. That's actually going to help us find the formula for the area of a parallelogram is sort of the relationship that a parallelogram has with a rectangle. If I were to cut that triangle off, I'm going to cut this triangle right here off of my figure. I'm going to pick that triangle up and move it so that it's over here. And then what I've got is I've just made a shape that sure enough is a rectangle that has a length and a width. And it's that length and width that we are going to use when we go to find the formula for our parallelogram, because we are going to use the length along the bottom here that we're going to call the base, and the height, which is the vertical distance from the bottom of the parallelogram to the top, to give us the formula for the area of a parallelogram is going to be that the area is equal to the base multiplied by the height. That'll be the formula for the area of a parallelogram. For the perimeter, we're just going to add up all four sides. Let's take a look at how this works. Find the perimeter and area of the figure below. So the first thing we were told to do is find the perimeter. So that's what we'll do first. And the perimeter, remember, is if I were to start up here and walk my way all the way around the figure, that how far would I have to go? And one of the things that I'll need here is I'll need to know the lengths of all the sides. Well, if the bottom is 8, then the top is also 8. And if the left side is 3, then the right side is also 3. So now I have all my dimensions, and I can add these up to find the perimeter. One thing you want to be careful of here, remember, when we're finding perimeter, it's just walking around the outside edges of the figure. So that's the 8 plus the 3 plus the 8 plus the 3. We're not going to use that 2 when we find perimeter, because that's not a part of the exterior of the shape. That's a line drawn through the inside, so it's not part of the perimeter. So when I go to find the perimeter, I'm just going to add up those four numbers, 8 plus 3 plus 8 plus 3. We'll have 8 plus 3 plus 8 plus 3. Let's see, that's 11 plus 11 more is 22. This particular diagram didn't give us units. This could be inches or centimeters or feet or yards. We don't really know, so we'll just call it 22. Now notice we didn't use that number 2 when we were finding the perimeter, so I wonder if it has any purpose at all. And sure enough, it does, because when we go to find the area of this parallelogram, we're going to multiply base times height. And the base is the bottom down here, that's this 8. And the height, that's where that 2 comes into play. And so the area of this parallelogram is going to be the base multiplied by the height, or 16. And again, we don't have units here. It could be square inches, square feet, square centimeters. For this one, we'll just call it 16. Next thing we're going to look at are trapezoids. Now, trapezoids got a relationship with a rectangle in there, kind of, except both ends of the top have, instead of being shifted, they've been kind of squeezed in. So we are going to have a height in a trapezoid the same way that we did in our parallelogram. But in this case, the bottom of my trapezoid, which we are going to call the base with a capital B, and the top of my trapezoid, which instead of calling it top, we're going to call it a base with the lowercase b. The reason they're both bases is it could be drawn upside down. So the way we've got it oriented, we have a bottom and a top, but it could be flipped over. And so we're going to call the longer side B with a capital B, and the shorter side B with a lowercase b. And so I've got two different bases here and a height. What we're going to do to find the area of a trapezoid, we are going to find the average of the two bases. So I'm going to say that'll be capital B plus lowercase b over 2. So in other words, what we're kind of finding here is the average width across the trapezoid. That's where that comes from. And then we're going to multiply that by the height to get the area of the entire figure. So it's the average of the bases multiplied by the height. That's how we'll find the area of a trapezoid. Let's take a look at one. Find the perimeter and area of the figure below. Again, the first thing we were asked for was perimeter. And remember, perimeter is going to be the distance around the outside of the figure. So please take special note of the fact that the 7 is not going to be a part of the perimeter of this figure. It's just going to be around the outside edges. I wasn't given all of the numbers here, but I guess since I've got a 9 on that side, I can be confident that there's going to be a 9 on that side as well. And now I can find my perimeter. And that's going to be 10 plus 9 plus 15 plus 9. I'll add up all 4 sides to get my perimeter. Let's see, 10 plus 9 would be 19, plus 15 would be 34, plus 9 more is 43. And here again, we don't have units, so we're just adding these up and it's 43. Could be inches, feet, centimeters, yards, miles, but here we'll just go with 43. Then we also need to find the area of this figure. And the area of this figure is going to be the average of the bases multiplied by the height. So I want to identify the numbers that are going to come into play here. And these are my 2 bases, and this is my height. So the 9s aren't going to get used here because all we're interested in are the 2 bases and the height. What I'll have is the base on the bottom plus the base on the top divided by 2 multiplied by the height, which is 7. So here I have 15 plus 10, that's 25 over 2 multiplied by 7. And so that's 12.5 multiplied by 7. And so the area of this trapezoid is 87.5. Again, we don't know what the units are. Could be square feet, could be square yards, could be square centimeters. But we do know that the area of this figure is 87.5.